Let's use a table of integrals to evaluate this indefinite integral. Again, it's not providing us with the table of integrals, so let's use the table that I will provide to you and is available on document share. So we're looking for x over constant minus x in the denominator. So I want constant minus x in the denominator. So let's just start at the top and look for something like that. It's not going to be any of these basic integrals. It's not a trig integral. It's not a reduction formula for a trig integral. It's not a squared minus x squared, and it's not x squared minus a squared. It's not a squared plus x squared. All right, here we go. It's going to be ax plus or minus b. That's what we're looking for. Okay, so let's try to find one that matches exactly what we've got. And if we look carefully, you should be able to notice that we can make number 79 match what we've got. However, even by using number 79, we are going to need to be careful. Right? We have to look at what the rules are up here. Ax plus or minus b, that's fine. A is not equal to 0. That works for us just fine as well because the a is the constant of x. The coefficient of x does not have a 0 in it, but it does require that b be positive. Or b must be bigger than 0. Can we make that true here? In the way that it's given here, the b value is the constant that does not belong with x in the denominator, and that's negative 2. So far that's a problem. Right? B is not positive in order to use integral number 79 here. So we actually have to do some algebra first in order to make that work. What we're going to do is factor a negative 1 out of the denominator. If I factor a negative 1 out of the denominator, and then I can factor that negative 1 all the way out front, this actually becomes 2 plus 3x. So by taking a negative all the way outside, I actually get 3x plus 2, which matches number 79 exactly, with a being 3 and b being 2. So what I want is a is 3, b is 2, but I want a negative all the way out front. Okay, so let's write that down somewhere so that we can see what's happening and then match it to what we're given. And so I'm going to just use Word to scratch out some work on here because we're recording on the computer. You would likely just use a piece of paper and write this down. What are we looking for here? We're using number 79. Remember that we've got that a is 2, a is 3, actually, the coefficient of x. We're using that b is equal to 2. And don't forget that we have a negative all the way out front. So this will be negative. We have a negative from factoring these negatives out of the denominator. Negative x over a, which is 3, minus b over 2, so b over a squared. So that's going to be 2 over 9. That's b over a squared. Natural log, absolute value of ax is 3x, b is 2. Absolute value of 3x plus 2, that's the absolute value, plus c. So, and then all of that ending parentheses is making it negative. If I distribute the negative sign through, that's negative x over 3 plus 2 over 9 times ln absolute value 3x plus 2. So now we've got to match this up to one of our potential answers over here. So I'm seeing a negative x over 3, which means that I like either b or I like d at this point. I'm also seeing a 2 over 9, so the only one that has this 2 over 9 is choice B. We have to be a little bit careful because choice B doesn't quite match up what we wrote down. Because we wrote down 3x plus 2, and they're showing us negative 3x minus 2. But really notice that these are the same thing, because this is absolute value. And so if I take a negative out of both of these, the absolute value would make that negative go away, and it would look exactly like what we came up with using our table over there.